Hi everyone, welcome to Math Learning Hub again, which is a hub for everybody who loves math. And this is Shania, and today I'll be teaching you about the LCM of two numbers. So what is the LCM? So the LCM stands for the least common multiple, and it's pretty self-explanatory, right? So it's the least common multiple that two numbers have in common. So I think this is better illustrated with an example. So let's take 9 and 12, right? So with 9, we're just going to go and list the multiples, and we're going to go and list the multiples of 12 and see which is the least multiple they have in common, right? So multiples of 9, you can see that we already have them listed here. They're 9, 18, 27, 36, 45, 54, etc. So basically all the multiples of 9, right? And then the multiples of 12 are 12, 24, 36, 48, 60. You can go on, 72, etc. But you notice that the least multiple that they have in common here is 36, right? The least multiple other than like 1 that they have in common is 36. And therefore, the LCM of 9 and 12 is 36. So that's a bit of an idea what LCM is. However, if you want to find LCM, listing out the multiples is, of course, not the easiest way. So we're going to try to see if there's another way, and it turns out that there is. You can use prime factorization in order to find the LCM, right? Prime factorization. So we're going to illustrate this with two numbers, which are 32 and 40. Right? So if we take the prime factorization of 32 and compare it with the prime factorization of 40, which we've already done here, to find the least common multiple, you take the highest power of each prime factor and you multiply it together. So let me repeat that. You take the highest power of each prime factor and you multiply it together, right? So in this case, let's take 40 and 32. So you see both have both have a prime factor of 2. Well, what's the highest power of 2 there is, right? Well, you have 2 to the power of 3, and you also have 2 to the power of 5. The highest power would be 2 to the power of 5. So if you take that over here, and then you also notice that you have a factor of 5, right? You have a prime factor of 5. And since you only have it in one number, the highest power is just the power is in that one number, which is 40 in this case. So the highest power here would be 5 to the power of 1, right? Or just 5 if you want to make it simpler like this. So when you multiply these two numbers together, you'd get the LCM, or the least common multiple that is in common between 40 and 32. In this case, that's 2 to the power of 5 times 5, which is 160. Therefore, the LCM is 160 here. So now I'm going to let you guys try it. So I'll let you pause the video, do these 3 problems, and then I will go over them once I resume the video. Okay, so I hope you paused the video and took time to do these 3 problems. I worked them out for you this time, and I will go ahead and give the answers. So to problem number 1, find the LCM of 24 and 36. So first, recall that the first step is to prime factorize the two numbers, right? I'm assuming you already know how to prime factorize here. If not, you can refer back to my GCF and factorizing video. But I made the factor trees for 24 and 36. So I found that 24 prime factorization is equal to 2 cubed times 3. And 36, the prime factorization is equal to 2 squared times 3 squared. So to find the LCM, if you recall, you need to take the highest power of each prime factor, right? So looking at 2, right? Looking at the prime factor 2. The highest power of 2 that we have is 2 to the power of 3, right? And similarly, looking at 3, the highest power of 3 we have is 3 to the power of 2. So you would basically take those two high powers and multiply them together. So in this case, it's 2 cubed times 3 squared, which is equal to 72. This is the LCM of 24 and 36. I'll leave that up for a bit so you can look at it. Okay, moving on to question 2. So question 2 asks, find the LCM of 108 and 128. So I prime factorized 108. The factor tree is shown right here, but basically what I got was 2 squared times 3 cubed. And 128, I memorized that that was the power of 2 since I know my powers of 2 up until like 10 or 12. So basically to find the LCM of these two numbers, you basically just take the highest power of each prime factor, right? So for 2, right, for 2, you have 2 to the power of 2, and you have 2 to the power of 7. So the highest power of 2 here is 2 to the power of 7, which is written here. And then you have 3 to the power of 3 also as a factor, right? So that's the highest power of 3 that you have, is 3 to the power of 3. So you also have to multiply it here. So the LCM is just basically 2 to the 7th times 3 to the power of 3, which is equal to 3,456. So I'll leave that here so you can get a good look at it. Okay, so now for question number 3. Question number 3 has 3 numbers. That's 40, now same of 48, 72, and 108. So this might seem a bit challenging at first because it's 3 numbers, but in reality, you basically use the same method. So you prime factorize each of the numbers, which I have done here. And then again, you just take the highest power of each of the prime factors within those 3 numbers. So for instance, for powers of 2, right, you have 2 to the power of 4, 2 to the power of 3, and also 2 to the power of 2. So what's the highest power of 2 you have? Well, that's just 2 to the power of 4, right? So you write that here. And then what about the powers of 3? Well, you have 3, which is 3 to the power of 1, basically. You have 3 to the power of 2, and you also have 3 to the power of 3. So the highest power of 3 you have is 3 to the power of 3. And then you don't have any other powers of any prime factors. So you just multiply those two together and you get 432 as your final answer. So I hope these examples were helpful. And before I go, I just want to give a little bit of side note about LCM and GCF. If you have a prime factorization where it's more than 2 prime factors, right? Suppose like instead of 108 here, you had a number with the prime factorization. Instead of this, you had, let me change my color actually. So instead of this, you had 2 to the power of 2 times 3 to the power of 3 times 5, right? Times 5. And you wanted to find the LCM of this number with this prime factorization and this prime factorization. You'd basically follow the same processes, but you notice that there's a 5 here, so you need to take the 5 into account. So in addition to multiplying 2 to the 4th and 3 cubed like you did here, you would also need to multiply this by 5, right? Because you need to multiply it by the highest power of every prime factor. Since you have 5 as a prime factor, you also need to multiply it by the highest power of 5. If this was 5 to the power of 2, right? 5 to the power of 2, you'd also multiply this by 5 to the power of 2. And yeah, also a pretty cool thing to know that can help you sometimes. So if you have a number m and a number n, those two are both numbers, right? So the LCM of M and N times the GCF of M and N is just equal to M times N, right? It's equal to M times N. And looking at how you find the LCM and how you find the GCF, I'm going to leave you to figure out why that is true. Just a little exercise for the viewer. Okay, but that should be it for our lesson about the LCM. Thank you all for logging in and watching. And if you want to see more content, then please be sure to subscribe to Math Learning Hub. And that will be the end of the video. See you in the next one. Bye.